In the next couple videos, I'm going to use induction to prove that each of these are true. So in this video, I'd like to show that number 1 is true. So for number 1, I'll call it s of n, and this is equal to 2 to the 2n minus 3n minus 1. And what we're trying to prove here is that for values of n, that this is divisible by none. And if you check for n equals 1, 2, 3, and so on, you will see that it is indeed true, just by plugging in numbers. But to prove it by induction, we're going to assume that s of n is divisible by 9. And then all we need to show is that s of n plus 1 is also divisible by 9. To do this, I just need to put n plus 1 in here. So s of n plus 1 is equal to 2 to the 2 times n plus 1 minus 3 times n plus 1 minus 1. And if I simplify this, I have 2 to the 2n plus 2 minus 3n minus 3 minus 1. And then here I can separate this into 2 to the 2n times 2 squared minus 3n minus 4. And then this simplifies to 4. So now I have 4 times 2 to the 2n minus 3n minus 4. And in many proof by induction problems, it's helpful to see if you can get back the original equation. So if we can somehow algebraically manipulate this to get back s of n, then that might help us. So if we recall the original s of n, we had a 1 for the constant and a 2 to the 2n for the first term. And notice here we have 4 times that 1 and 4 times 2 to the 2n. So if we can somehow make this 4 times 3n, then we can get back our s of n by factoring out 4. And the way to do that is to just add 9n and subtract 9n. Since with expressions, we can really only add and subtract the same number or multiply the whole thing by 1. Once we do this, our equation will simplify to 4 times 2 to the 2n minus 12n now, minus 4 and then plus 9n. And so notice that now each of these terms here are divisible by 4. So I'll factor out a 4 from everything. I have 2 to the 2n minus 3n minus 1 plus 9n. And notice here that this is just s of n. And we've assumed that s of n is divisible by 9. And then this term here would also be divisible by 9, since whatever number n I put in here, it's always going to be multiplied by 9. So you could always divide this by 9. And so if both of these terms are divisible by 9, therefore the whole thing is divisible by 9. So that proves that s of n plus 1, is divisible by 9.